Hey guys, just got the hand of the Specialist Maths Exam 1, so without further ado, let's get started. Okay, so the question number 1, consider the function with the rule is okay, so verify that this is a factor of that. Okay, cool, so that means 3z plus 2i equals to 0, so z is equals to minus 2 on 3i. Now we just simply substitute that back in, so minus 2i on 3 equals to 3 times minus 2i on 3 cubed plus 2i on minus 2i on 3 squared plus 3 times minus 2i on 3 plus 2i. Okay, so this would simplify to minus 8i cubed. Yeah, minus 8i on 9. This would simplify to positive 8i on 9. This would be minus 2i, oh, not vector, plus 2i. Okay, so yeah, that is 0. So that's done. Verification is done. Hence or otherwise, solve the equation this. Give your answers in Cartesian form. Okay, well in that case, I think we have to do a long division to find the other factors. So let us quickly do that. So 3z plus 2i, and then 3z cubed, what was it? Yep, plus 2iz squared plus 3z plus 2i. So z squared, 3z cubed plus 2iz squared, take away 0 iz squared plus 3z, so that would be plus 0 z, so that will be 0 0 z squared plus 0 z, so that would be 3z plus 2i. So everything is 0 anyway, so it doesn't matter if I write I or not. So yeah, plus 1, 3z plus 2i. There you go. Okay, so fz is equals to 3z plus 2i, z squared plus 0z plus 1, and that has to be equal to 0, so fz is equals to 0. So our roots are going to be z is equals to minus 2 on 3i, and this one is going to be z squared plus 1 is equal to 0, so z is equals to plus or minus I. So our roots are going to be this and that. Alright, so plot the solutions of fz on Argand diagram below. Okay, so this one is z is equals to I, this one is z is equals to minus I, and the other one was 2 on 3. Okay, negative 2 on 3, so z is equals to minus 2 on 3i. Okay, prove that if x is an odd integer, then this is even using a direct proof. Okay, so yeah, so x, for it to be an odd number, our odd number can be written like 2n plus 1, right? The reason being an n here is any integer, because what we are doing is we are timesing it by 2 first, so that means it would become an even number, and then we are adding 1, so it will become an odd number at the end of the day. Even if we, if n is an odd number, we times it by 2 becomes even, add 1 again becomes odd. So you can also do 2n minus 1, but either of them is fine. So now the second thing we know is that if you want to just an even number, we need 2n, where again n is an integer. So no matter what the number is, odd, even, if you multiply it by 2, we'll get an even number, which makes sense. Okay, now we just simply substitute. Well, let me write it down. So this is for odd, and this is for even. Okay, so now we substitute the odd number in here. So 2n plus 1 squared minus 3, 2n plus 1 minus 7. So 4n squared plus 4n plus 1 minus 6n minus 6 minus 7, oh, minus 3, sorry, not minus 6, minus 3. So that will be 8n squared plus 8n plus 2 minus 6n minus 10. So we get 8n squared plus 2n and minus 8. Okay, so notice how we can take 2 as a common factor. So 2, 8n squared, oh sorry, 4n squared plus n minus 4. Okay, now we discussed that for it to be an even number, our n here is the same as what we have here. So rather than writing n, what I'm going to do, I might just say this is k. And yeah, so our k, for example, here is going to be k is equals to 4n squared plus n minus 4, which if we substitute that here, we get an even number. So that's how we can prove that, yeah, that's how we can prove the things. Okay, so next question. So our f of x is this. This can be written in the form of this. Show that a equals to 1, b equals to minus 4, and c is equal to 4. Okay, so x minus 1 whole squared divided by x plus 1 whole squared is equals to a plus b on x plus 1 plus c on x plus 1 whole squared. Okay, so we times it by 2, times it by x plus 1 whole squared, I mean. So x minus 1 squared is equals to a times x plus 1 whole squared plus b times x plus 1 plus c. Now we just have to solve this. So x squared minus 2x plus 1 is equals to a x squared plus 2ax plus a plus bx plus b plus c. Okay, so then that means that our ax squared is going to be x squared, which implies that a is equals to 1. The next thing we have is 2a plus b is equals to minus 2. Now we know that a is 1, so 2 plus b is equals to minus 2, b is equals to minus 4. The next thing is the 1, so a plus b plus c has to be equals to 1. Sorry. We know that 1 plus, or minus 4, sorry, 1 plus 1 minus 4 plus c is equals to 1, so minus 3 plus c is equals to 1, which implies that c is equals to 4. So does that meet everything? Yeah. Okay, so therefore a is equals to 1, b is equals to minus 4, and c is equals to 4. Okay, so that's proved. So the graph of f has one turning point. Find the coordinates of this turning point. Okay, well I guess we can just simply differentiate the function. So our f of x is x minus 1 whole squared over x plus 1 whole squared, which can be written as x minus 1 whole squared x plus 1 to the power of negative 2. So now we can just simply apply the product rule. So that would become 2x minus 1 times, well, differentiate the inside, so that's just going to be 1, so I'm not going to write that down. X plus 1 to the power of minus 2. Now we differentiate the second term, so we get x minus 1 whole squared, that remains the same, times by minus 2, x plus 1 to the power of minus 3. Again, we have to differentiate the inside, but it's just going to be 1, so not going to write that down. Okay, we can actually write this as, what was it, minus 2x minus 1 whole squared times by x plus 1 minus to the power of minus cubed. I think that's all correct. Yeah, okay, so now we just have to set this equals to 0. Okay, so x minus 1 x plus 1 to the power of minus 2, take away x minus 1 whole squared, x plus 1 to the power of minus 3. That has to be equal to 0. Okay, well, I just removed the 2, by the way, so if you're confused where the 2's are gone, so I just took them out as a common factor, removed them. Now we can take x minus 1 and x plus 1 to the power of minus 2 as a common factor, so that will leave us with 1 minus x minus 1 times x plus 1 to the power of minus 2 is equals to 0. Actually, I'm just going to add an additional bracket just so that I don't get confused later on. So next step would be x minus 1 x plus 1 to the power of minus 2 is equals to 0. So well, we can write this as x minus 1 x plus 1 whole squared equals to 0, so this would just become 0. So for this, our answer is just going to be x equals to 1. And for the next case, we'll have 1 minus, wait, this is meant to be minus 1. Yeah, okay. Yeah, okay, that makes sense. So then this would be x minus 1 over x plus 1 is equals to 0. So x minus 1 over x plus 1 is equals to 1, because, well, when this goes to the other side, this will become negative 1, negative will cancel out, so I just skipped a couple of steps here again, and this will get us x minus 1 is equals to x plus 1. Okay, well, this is just not gonna work. X minus x is 0. 0 is not equals to 2, so that is not the solution. So this is the only one, so now we just put it back in. So we get 0. Yeah, 1 minus 1 whole square 0. Yeah, okay. So our turning point is equals to 1 and 0. Okay, coolio. So we label everything up, so 1 and 0, that's okay, our turning point. What about our y-intercept? So 0, f of 0, so then we get minus 1 squared over 1 squared, so that's 1. So it's gonna be like this. And then our asymptotes actually, so what will be our asymptotes? Yeah, one of them will be x is equals to minus 1, so just here. And the other one would be y equals to 1, I believe. Yeah, because if y was equals to 1, say for example, we would have x plus 1 whole squared is equals to x minus 1 whole squared. Now that would kind of become the situation we had here. So yeah, y equals to 1 is also one of the asymptotes. Okay. I think that's it for the asymptote. We just label them. Oh, y equals to 1 and x equals to minus 1. Oh, and please make sure your lines are dotted and not what I've drawn here. So it's like this. Yep, that would do. Okay, now I'll substitute in another point. So f of minus 2 maybe to get the scaling right. Okay, so f of, the reason why I picked minus 2 is that so that it's easier to simplify. So this would just become 1, and then the above function will, the numerator will become 9 basically. So f of minus 2 is 9. So our graph is going to be off the grid essentially. This is going to be one of those weird graph where it's like this basically, something like that. Yeah, I've came across this when I was doing my SAC and stuff at school. So yeah. Okay, anyway, so this is going to be like off the chart, so I'm just gonna say it's here and plot the graph accordingly, like that. I think that would do, and this is going that way. Now this is going like that and then going back up like this. Okay, cool. So we label our points 1 and 0, then 0 and 1. Okay. Consider the vectors A, B, and C. Find the angle between A and B. Okay, so that is just simply doing dot product. And then, yeah. So, let's do the dot product. That would be 0i plus 3j plus 3k. I always tend to write 0i or whatever component is 0 to avoid making silly mistakes. And then dot product 2i minus j minus k. Okay, so we get 0 and then minus 3 and then minus 6. So that is equals to minus 9. Okay, well, so the dot product isn't going to be 0. Okay, so in that case, we'll calculate the magnitude as well. So we'll get 3 squared plus 3 squared, so 18, which is 9 times 2, so 3 root 2. And our magnitude of vector B is going to be, so 4 plus 1 plus 4, so that's just 9. And our square root of 9, so that is going to be 3. That is going to be 3. Okay, so then our cos theta is equals to minus 9. Okay, let me write the formula down. So that over magnitudes of A and magnitude of B. So minus 9 over 3 times 3 root 3, so 9 root 2, which is equals to minus 1 on root 2. So cosine of theta is equals to minus 1 on root 2. So our theta is going to be 3 pi on 4. Yeah, because, you know, in the unit circle, cosine is negative in these two quadrants. So yeah, it's going to be 3 pi on 4. Okay. Find all the possible values of n such that the dot product of A and C is equals to the magnitude of the cross product of A and C. Okay, so let's start by doing the dot product again. So it will be 0i plus 3j, plus 3k, and dot product ni plus 2j plus k. Okay, so we'll get 0 plus 6 plus 3, which is equals to 9, so that would just be 9. And now we will do the cross product. So A cross C, that is just going to be I, the determinant thing, so ijk, and 0, 3, 3, and 2, and 1. So that would equals to I times 3 times 1 minus 2 times 3, so 6, minus j, which is going to be 0 times 1, which is 0, and 3 minus 3 times n, so minus 3n, plus k times 0 times 2 is 0, minus 3n. So simplifying this, we'll get minus 3i plus 3nj minus 3nk. And we'll find the magnitude, such that the dot product, so we'll find the magnitude of the cross product that we just did. So that is going to be 9 plus 9n squared plus 9n squared, which is 9 plus 18n squared, which has to be equals to 9. So you can simplify the inside, so 9 times 1 plus 2n squared equals to 9, so we'll get 1 plus 2n squared is equals to 9 divided by 3, so 3. So 1 plus 2n squared is equals to 9 2n squared is equals to 8, n squared equals to 4, so our n is going to be 2 and n is going to be minus 2. So these are solutions. Wait, let me check if there's any domain for n. Okay, it's just an integer. Cool. Alright, the curve with equation this for this domain where k is greater than 2 is rotated about the x-axis to form solid of revolution that has a volume of 7 pi on 2 units cubed. Show that k satisfies the equation this. Okay, well, so we know that the volume formula is just pi times 1 to k on 2 y squared dx, and that has to equals to 7 pi on 2, right? So we'll get pi times 1 on k, 1 to k on 2, k minus 1 on x squared dx is equals to 7 pi on 2, k 1, k on 2, k minus 1 on x squared dx, which is equals to 7 on 2. I took the pi out of here. Okay, which is equals to, now we just simply integrate, so kx minus so that will be plus 1 on x, plus 1 on x, well, long bracket, 1 and k on 2, that is equals to 7 on 2, of course. So now substitute in, so k squared on 2 plus 2 on k minus k plus 1 has to be 7 on 2. Okay, so k square on 2 plus 2 on k minus 1 is equals to 7 on 2. So k squared on 2 plus 2k minus k equals to 9 on 2. Okay, so now we make the denominator the same. So k squared, k cubed minus 4 minus 2k squared over 2k is equals to 9 on 2. Yep. Okay, I'm just checking if I've done it correctly. Yep, okay. So 2k cubed minus 8 minus 4k squared is equals to 18k. Yep, so then 2k cubed minus 4k squared minus 18k minus 8 is equals to 0. So now we just divide by 2, so k cubed minus 2k squared minus 9k minus 4 equals to 0. Okay, does this match? So k cubed minus and plus. Okay, we're getting minus for 4. Why is that? Oh, yeah, okay, obviously it's plus. Yeah, plus and plus. I think that should be all good now. Yeah, okay. Alright, wow, that's a long thing to read. The production of a brand of a wheat trimmer involves 3 stages, stage 1, 2, and 3, which takes this, and this hours respectively. Here, this, and this are independent random variables, okay, which may be assumed to be normally distributed. Assume that stage 2 starts immediately after stage 1 and stage 3 starts immediately after stage 2. The mean, standard deviation, and costs at each stage are shown in the table below. Find the mean and variance of the total time to produce one weed trimmer. Okay, well, so that's pretty simple. So EW, or maybe I can say ET is equals to EW1 plus W2 plus W3. So that is equals to EW1 plus EW2 plus W3. So that is just 1 plus 1.5 plus 2, which is equals to 4.5 hours. So now we'll say the variance of the time, which is going to be same thing. So variance that plus that plus that. So we'll get variance of this plus variance of this plus variance of W3. W3, there we go. Okay, we don't have the variance, but we have the standard deviation, so we can just square them. So 0.3 squared plus 0.4 squared plus 0.5 squared, so we'll get 0.09 plus 0.16 plus 0.25, so that is equals to 0.5. Yeah, 16 and 9 is 25. Yeah, hours squared. Yeah, the unit is pretty weird. Hours squared, it's variance. So yeah, find the variance of the total cost to produce one weed trimmer. Okay, so variance of the cost is then going to be, well, we are given the cost per hour, so we can just use that. So we got variance 10, yep, so 20 W2 plus 15 W3, right? Yeah, because cost per hour and the time. Yeah, okay, yeah, just making sure. Alright, and then this would then become 100 variance times W1. Well, the 100 comes from, because if we have AX plus B, then this would be A squared variance of X. It's in your formula sheet as well, so yeah. Anyway, let's continue. Plus 400 variance W2 plus 2 to 5 variance of W3. Okay, again, we do not have the variance, so we just use the standard deviation. So 100 times 0.09 plus 400 times 0.16 plus 225 times 0.25. Okay, maybe I'll just make them a fraction. So 9 over 100 plus 400 times 16 on 100 plus 225 times 1 on 4. Okay, so this will just become 9 plus, so this cancels out 4, so 64 plus, yeah, that doesn't simplify, so 225 on 4. Okay, so we'll get 36 plus 64 times 4 is, yeah, 256 plus 225 on 4, so add everything up, so 256, this would be 11, 8 and 4 plus 36, 7, 11 and 5. Okay, so 517 on 4 is going to be our answer, and of course we have the unit as dollar squared. Alright, should be good. Okay, if a single weed trimmer is produced, find the probability that the time spent at stage 2 will be less than the time spent at stage 1. Give your answer correct to 2 decimal places. Okay, use this, okay, whereas that is a standard normal variable with mean of 0 and standard deviation of 1. Right. Okay, so in that case, we'll just let D equals to W1 minus W2, and we want to basically find probability that D is greater than 0. So let's start finding the mean. So that will be EW1 minus EW2. So what was the mean? So that was 1 minus 1.5. 1 minus 1.5, which is 0.5, of course, minus hours. Okay, then we'll find the standard deviation, but we'll start with the variance. So variance of D is going to be W1 plus variance of W2. Okay, so variance of W1 again would just be 0.09. 0.09 plus 0.16 as calculated previously already, so that would result in 0.25 hours squared. So that means our standard deviation is going to be square root of variance, which is going to be 0.25 square root, and that would be 0.5 hours. Okay. Now we have to use the standard normal. So in this case, probability that d is greater than 0, we can also express this as probability that z is greater than 0 minus mean, which was 0. Minus 0.5 divided by the standard deviation, so 0.5. Okay, so that would result in probability of z is greater than 1, I mean. Yep. And we are given that this is 0.68. So basically, if I were to draw my bell curve, okay, let's try again. Okay, good enough. So from here to here, this region over here is 0.64. This is our 1 and this is our -1. And what we have to find is the region here. This is the region that we are after. So 0.68. Now we also know that this region over here adds up to 0.5, right? Correct? So that means from here, wait, this is a bit too messy. Okay, anyway, so the entire region here adds up to 0.5, right? And this section over here is going to be 0.34, which is 0.68 divided by 2. So then we can say 0.34 plus probability of z is greater than 1 is equals to 0.5. So therefore, our probability that z is greater than 1 is 0.16. And this is going to be our final answer. Yeah, okay, cool. So solve the differential equation expressing y as a function of x given that y of 0 is -2. Okay, so x plus 2y, x squared plus 1 dy dx is equals to 0. So we have 2y x squared plus 1 dy dx is equals to -x. So x squared plus 1 actually, yeah, we can just say 2 dy dx is equals to -x on x squared plus 1. Yeah, okay, so now we get 2y dy is equals to that divided by x squared plus 1 dx. Integrate both sides. So here we simply just get, so integrating 2y dy is just y squared. And now we have to integrate this, but we have to use substitution method, of course. So integrating -x on x squared plus 1 dx. Alright, so let u equals to x squared plus 1, so du dx is equals to 2x, which implies that dx equals to du on 2x. So now the integral will become -1 on 2. So basically, if I were to show these steps, it would become -x on square root of x squared plus 1, which is just square root of u at this point, times by du on 2x. So now I can just simply write, which is equals to -1/2 integral of 1 on root u, 1 over root u du. But don't include this step because that's like multiple variables, so you may get penalized for wrong mathematical notation. Okay, now we'll just integrate this. So this can also be expressed as u to the power of -1/2 du, and integrating this will give us 2 root u, and this will be minus root u. So our answer would be minus x squared plus 1 plus c. Oh wait, I forgot 2 plus c here. So plus c1 and plus c2. So now equating everything together, so y squared plus c1 is equals to minus x squared plus 1 c2. So we can express this as y squared is equals to minus x squared plus 1 plus c, because c2 minus c1 is also a constant, and I'm just going to call that as c. Okay, now we know that y of 0 was what? Yeah, minus 2. So minus 2 squared is 4 is equals to minus 1 plus c. So that would become minus 1 plus c. So c is just going to be 5. So y squared is equals to minus x squared plus 1 plus 5. Okay, so then this will become plus or minus negative x squared plus 1 plus 5 to the power of a half, which is just square root. Now, yeah, okay, because y0 is less than 0, because y0 is less than 0, since y0 is less than 0, we'll pick the negative root here, minus x squared plus 1 plus 5 to the power of a half. This should be your answer, as long as I haven't made any calculation error. I guess looks okay. Moving on, I guess. Okay, so using implicit differentiation, show that given that 2xy can't be negative 1, and this is our relation over here. Very well, so we just use the product rule. So we have 2xy squared plus 2yx squared dy dx plus y plus x dy dx is equals to 0. So then we will combine the like terms, so 2yx squared plus, oh wait, dy dx plus x dy dx is equals to minus 2xy squared minus y. So then we'll take out dy dx as common, dy dx 2yx squared plus x is equals to minus 2xy squared minus y. So our dy dx is going to be minus 2xy squared minus y over 2yx squared plus x. Okay, yeah, we can take out y and x respectively. So negative y, we'll take that out. We'll get 2xy plus 1 divided by x on 2xy plus 1. So this and this would cancel out. Therefore, dy dx is equals to minus y on x. Okay. Find all the points on the graph where the slope of the tangent is equals to minus 1. Okay, so dy dx is equals to minus 1. So we get negative y on x is equals to minus 1. So y is going to be equal to x. So we substitute that back in the equation. So x squared, well, x to the power of 4 now, plus x squared is equals to 2. So x to the power of 4 plus x squared minus 2 is equals to 0. Let a is equals to x squared. So we'll have a squared plus a minus 2 is equals to 0. Okay, so a minus 1 and a plus 2 is equal to 0. Substitute the x squared back in. X squared minus 1 and x squared plus 2 is equals to 0. So x is equals to 1 and x is equals to minus 1. X squared plus 2 cannot be 0, right? Okay. So in that case, our answer is going to be 1 and 2. and negative 1 and 2, because, well, no matter what we put in here, we'll always get 2. So yeah, so this is going to be our answer. Okay, let's move on to the next question. A car is traveling along a straight flat road. The velocity v kilometer per hour of the car and its position x kilometers are measured from the position on the road where x is 0. The velocity and the position of the car are related by v square is equals to the whole thing, where x is between negative 15 and 15 and v is greater than or equal to 0. Okay, a speed detection device is positioned to detect the speed of the car as it passes the position x equal to 0. The speed limit on the road is this. The speed detection device will be activated if the car is traveling at 10% or 10% or more above the speed limit. Okay, so determine with evidence whether the speed detection will be activated. So first, I guess we will find the velocity when x is 0, so at initial position. So v squared is equals to 1600 plus 672 on pi arc cosine of 0, which is like pi on 2, so I'll just write that, so times by pi on 2. Cancel 2 and 3 and then another 3 and 6. So we'll have v squared is equals to 1600 plus 336. So v squared is equals to 1936. Right. Okay, how we can do this is, so let's find the 10% of 1600. So 1600, so 10% of that, so 0.1 of 1600, that would just be 160. Meaning that, okay, maybe I should write it in here. So 0.1 of 1600 is 160. Meaning that if v square is greater than 1600 plus 160, so 1760, device will be activated. Device will be activated. Therefore, and since v square is equals to 1936, device is activated. Okay, so the thing is, yeah, so what I did basically was the fact that we know that 1600, like if we square root 1600, we get 40. So that's already the speed limit of the road. And it's given that 10% or more above the speed limit will trigger the sensor. So what I did was, rather than finding the value of square root, I just simply found the 10% of 1600 and then found the maximum speed before, maximum v squared before the device, before the detection is actually activated, right? And the maximum of v square is here at 10% or more. So yeah, is equal, greater than or equal to. So this is the maximum basically of the v square. So since our v squared is higher than that, the speed device is going to be activated. That's the logic. Hopefully that made sense. Okay, so find acceleration of the car in kilometers per hour squared, where x is 12. Give your answer in the form of k on pi. Okay, so we know the form, right? That a is equals to d dx of 1 on 2 v squared. So since we already given v squared, we'll just divide it by 2, the whole thing, and then we'll get the form required. So v squared on 2 is equals to 800, I believe, 800 plus 672 divided by 2 is 336 pi arc cos x on 20. Now we'll just differentiate. So of course we state that that is what we are going to be using. So now a is equals to d dx of 800 plus 336 on pi arc cos of 80 on x on 20. Okay, so let me pull out the formula sheet for differentiating the cos inverse. Okay, so our a is going to be 336 pi times negative 1 on 20 divided by 1 minus x on 20 whole squared. Okay, now I'm not going to bother simplifying because that again opens the possibility to make errors while simplifying. So what I'm going to do, I'm just going to simply plug in the number that x is equals to 12. So when x is equals to 12, now we'll just substitute the 12 in. So a is equals to 336 on pi times minus 1 on 20 square root of 1 minus 12 on 20 whole squared, which is 4 on 5. No, 3 on 5 I mean. 3 on 5 whole squared, so 9 on 25. So that was equal to 336 on pi times minus 1 on 20 divided by square root of 16 on 25. Yep, so that is going to be divided by 5 on 4. Okay, so that is going to equal to 336 on pi times negative 1 on 20 times 4 on 5. And so now we get 5. So our answer is going to be 336 on 25 pi. Okay. Wait, our form actually doesn't quite match the answer because k is an integer, so k definitely cannot be minus 336 on 25. Okay, let us see, where have I made a mistake? Right, so yes, I've copied it correctly, the derivative, substituted that, so this will in return give us square root of 16 on 25. Oh, it will be 4 on 5, not 5 on 4. What am I doing? Okay, 4 on 5. There we go. Maybe this would be correct now. So 4 on 5. So, which is equals to 336 on pi times 1 on 20 negative 5 on 4. That would cancel out to 4. So this would be minus 336 on 16 pi. Does it cancel out by 16? I think it does. So 16 times 2, 1. Yeah. So our answer is going to be negative 21 on pi. What was the units? Kilometers per hour squared. Kilometers per hour squared. If you want to be safe, I'll just write k equals to minus 21, just to be very safe. Okay, but I don't think it's required. Anyway, I think this should be all good. We matched the form, so that's good. Okay, question 10. How many questions? Okay, good. This is the last question. Cool. So, let the lines L1 and L2 be defined by this. Okay, where M, it cannot be this, and lambda and mu is just, can be all real numbers. If the shortest distance between the two skew lines is this, find the values of M. Okay, so for that, let's find R1 of 0. So that would just be I plus 0j plus mk, right? And R2 of 0. So now we have like a point basically that we can use to calculate. So here we'll get 2i plus 0j minus k. Okay, now we have to find the shortest distance between the two skew lines. So for that, we need the perpendicular distance as well. So what we'll do is we'll take the cross product of this vector and this vector. Okay, so our d value, which is just going to be the cross product of I plus 2j plus k cross negative I plus 3j plus 2k. Okay, so that would equal to I, j, and k. So we'll get 1, 2, 1, minus 1, 3, 2. So then I would be 2 times 2, 4, minus 3, so 4 minus 3, take away j times 1 times 2, minus 1 times 1, so 2 plus 1, plus k times, so 1 times 3, so 3 plus 2. So we'll have our answer as I minus 3j plus 5k. Okay, so our D, the perpendicular distance between the two lines, is going to be this, minus 3. Well, it's going to be defined by the vector this. Okay, so in that case, what we'll do is we'll take the magnitude of this vector and then just simply scale it with by using these two. We'll subtract them and then we'll use that information. So that would be 1 plus 9 plus 25, so that will be square root of 35. So then now we have to find R2 minus R1, because that will give us the scaling factor. Currently we just have the perpendicular distance, now we have to scale it appropriately, so we'll just have to find that value. So we'll get we get 2i plus 0j minus k, take away I plus 0j plus mk. Copied right? Yes, I did. Okay. So we'll get I plus 0j minus k minus mk. So we can express this as I and minus k, 1 plus m. And now we just need to cross product the D, or not cross product, I mean the dot product between D and this vector, and then divide it by magnitude to find the, oh, and of course set it to the value given here, and that will give us the values or value for m. So our shortest distance is equal to mod of I minus 3j plus 5k dot product I minus, or maybe plus 0j minus k 1 plus m, okay, divided by square root of 35, which is the magnitude of the cross product vector, and that has to be, what was it, 14 on 35, 14 on square root of 35. Okay, so then we'll get 1 minus or plus 0, doesn't matter, minus 5 times 1 plus m is equals to 14, because just move this to the other side, cancels out, this and this will cancel out. Okay, so we'll get 1 minus 5 minus 5m equals to 14, so minus 4 minus 5m is equals to 14. And so we get minus 4 minus 5m plus or minus, is equal to plus or minus 14. So minus 4 minus 5m is equals to minus 14. So minus 5 equals to minus 10. So that says our m is going to be minus 2. And minus 4 minus 5m is equals to 14. So minus 5m is equals to 18. So our m is going to be minus 18 on 5. So these two are the m values I got. Okay, so m is all real numbers. So the chances our value is correct. Hopefully they are correct. Okay, that's it. Alright, well, hopefully you guys did good in this exam, and all the best for exam 2 tomorrow. Of course, let me know if I've made any calculation error, and I'm happy to rectify that in the comment section. Thank you for watching, and all the best for tomorrow. Bye bye.